house in Budapest, my hidden treasure chest, golden grand piano, my beauty focus EOU. Ooh, I'd leave it all.
Hey, what's going on, guys? Mr. Flores here. This video is the next in the series where we're talking about graphing linear equations, alright? And the last video talked about slope and how it interacts with the graph and how it's a constant rate of change. Now, this video is going to talk about x-intercepts and y-intercepts. So, basically, if you break them down, they both share the common word of intercept, okay? Really, to help out with how we're going to look at these and what happens on a graph is if you truly understand the definition of an intercept. So, really, an intercept is just when two things meet or they intercept each other or they intersect, okay? One of the ways I remember what an intercept or interception is, I should say, is when you think about football. For instance, an interception is where a defensive player and the football meet paths, and the defensive player gains possession of the ball. Another derivation of the term is if one of the first police cars, the model of the police car was called the Interceptor because cop cars are made to intercept bad guys. So the y-intercept and the x-intercept are two important things when it comes to graphs. All right, but oops, one too quick. Edit, redo. It's big because it's basically a point on a graph that's going to help us out a lot. So, for instance, if we look here, we have our orange graph. All right, it's a line. Okay, then it goes up, and then down. It kind of resembles a sine wave or a cosine wave, but that's not important. So, if we look here, our x-intercepts are wherever the graph, and it's our orange graph, intercepts or crosses the x-axis. All right. So if we look here, there's an x-intercept, there's an x-intercept, there's an x-intercept, and there's an x-intercept. All right. I guess I'll label. It's our x-axis, and then our y-axis. Oops, that's a backwards S. And our y-axis. All right. So therefore, our yellow or our orange line is intercepting the x-axis there, 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 and there. All right. The one common theme that we can notice from our graph is that all of the x-intercepts happen on the x-axis. All right. That's a given. But if we think, what is common between every single one of these points? And the thing that I'm trying to get at is if you look at this point right here in the middle, that's called our origin. And the coordinate of the origin is 0, 0, meaning the x value is 0, the y value is 0. But as we move left or right, if you think about it, the only value we're changing is our x. So if we move to the right, we're going up in the x's. If we move to the left, we're going down in the x's. So if we talk about our point right here, the coordinate's going to be 1, 2, 3, 4, 5, 6, 7, 8, -8. The y coordinate is still 0 because we didn't go up or down at all. You can't go back to your origin. Let's move here. This is about -3.5, comma, 0. Okay. Then we go here, 1, 2, 3, positive 3.5. Okay, 1, 2, positive 3.5 here. And again, our y is going to be 0. And then we go to the last one, 1, 2, 3, 4, 5, 6. We'll say it's here, it's 7, and it's 7, 0. All right, so if you notice, there's a reoccurring theme with every single one of our x-intercepts. If you notice all of the y coordinates are a big old 0. All right. That's going to play a big role in the next video when we talk about standard form, which is the first form of a line we're going to learn and how we're graphing it. But that's a big idea to understand that your x-intercept always has a y-coordinate of 0. That is because on the x-axis, you start at the origin and it moves horizontally left or right. Since we're not going up or down at all, our y value never changes as long as we go right from the origin on our x-axis. So that's, again, why the x-intercept, the y value is never going to change, right? And when we talk about our y-intercepts, the same idea kind of stays true. So here, let's look at our blue line now. All right. It crosses the y-axis here, since we're going to be looking at y-intercepts, here, here, and here. So there's, again, 4 y-intercepts. So again, I'm going to draw down here. Y-intercept. All right. So again, let's talk about this point again. And like I said, this is our origin, and the coordinate of the origin is 0, 0. So if we look here, let's count up to our highest point, which is up here. So let's go 1, 2, 3, 4, 5, 6, 7. Let's say it goes to here up 8. So the first y-intercept we're going to talk about is 0, 8. Because we started at origin and we just went straight up. We didn't move left or right at all. Our x value didn't change, so we're still at 0, 8. The next one, 1, 2, 3, 4. So it's going to be 0, 4. Go down 1, 2, 3. So it's 0, -3. And then we go down again 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's 0, -9. All right. Again, if we notice the reoccurring theme with our y-intercepts is that the x value is always going to be 0, because if you go from your origin straight up and down, we're not moving left or right at all. So we're not changing our x value in a negative or positive manner. It's actually just staying constant at 0. So your y-intercept always has a 0 coordinate, or a 0 value in the x coordinate. And just like I said about the x-intercepts, that is going to play a big role when we're graphing equations in standard form. So hopefully you guys understood that. This is just a quick short video on the intercepts of a graph. Again, the intercept is where it crosses that axis. So the x-intercept crosses the x-axis and always has a y-coordinate of 0. Your y-intercept crosses your y-axis and always has a x-coordinate of 0. And like I said, those are big ideas that are going to lead into the next video, which deals with standard form. If you guys have any questions, check out Derivative Dude or email me. Have a good one.